Venice, one of the world's most beautiful cities, was born of an audacious idea: to build a city on the water. The Serenissima rose from the mud of a marshy lagoon more than 1,500 years ago and has been withstanding attacks from the sea ever since. The water's constant threat is also the fount of the city's fortune and global renown.
The building of Venice is a miracle, really, when we understand how it's done and what it stands on and how it's managed to stand the test of time over all of these centuries.
Venice represents the ability to live in an impossible situation.
From the beginning, the builders of Venice have been continuously inventing and innovating to keep the city vibrant, vital, and dry.
The Venetians have always been amazingly adaptable to change, coming up with one ingenious solution after another for living on the water. Everyone is fascinated by Venice because it's like an open-air lab.
How did such an unlikely architectural masterpiece come to be? What pioneering techniques did the Venetians develop to wring sophisticated beauty from marshland mud?
Not many people know that Venice is built on millions of piles.
Though Venice has endured over the centuries, it's now locked in a race for survival against time and tide. What new challenges will the floating city face as the climate changes? And what extraordinary measures have the Venetians already taken to save their city?
Venice faces extraordinary challenges now and in the future, particularly from climate change and sea level rise.
Now, through spectacular locations, expert insights, and computer-generated images, you're about to plumb the depths of Venetian history to discover the secrets of the construction and conservation of this irreplaceable city. Venice, the queen of the Adriatic. Once the hub of the largest maritime empire of the day, it has now become an object of admiration for more than 30 million tourists each year. The history of Venice, which is located in Italy at the northernmost tip of the Adriatic Sea, is closely linked to that of its lagoon, a 550 square kilometer natural basin separated from the sea by vast rows of dunes with 3 openings. The water from the sea flows in and out of this gigantic reservoir through these gaps once every 6 hours according to the tides. In this city, unlike any other, the local population has always lived with the water. The city even resembles a large fish from up close. Over the centuries, Venice grew to become an artificial archipelago composed of 118 small islands separated by 176 canals, forming a network of nearly 50 kilometers of waterways. The Grand Canal is the longest, most beautiful, and most famous in Venice.
The Grand Canal is Venice's main thoroughfare, the largest waterway in the city. Moreover, it was this canal that gave the city its overall shape.
The many islands in the agglomeration are connected by more than 400 bridges. Unsurprisingly, Venice has more bridges than any other city in the world. But the Venice we admire today has little in common with the way it originally looked. 1,600 years ago, this was nothing but a marshy lagoon.
Venice was born in an exceptional environment because, not like other cities, it was created in the middle of a lagoon on a series of islands. So it's a swampy and difficult environment to build a city, not at all a hospitable place to try and build the city that will become one of the great cities of history.
So why did the future Venetians decide to settle in such a hostile environment? To find out, we have to go back to the beginning. In the 2nd century, just 11 kilometers from Venice's current location, the port of Eltinum prospered under Roman domination. But in the 5th century, Attila and his Huns took over Central Europe. 100 years later, the Slavs descended upon Eastern Europe and the Lombards reached the Po Valley. The local people were terrified and had to flee the invaders who were surrounding them from all sides. They had no choice but to take refuge in the lagoon.
The lagoon offered shelter, especially against invaders on horseback, so it was a source of protection.
It may have offered protection, but it also posed a problem. How to build houses in a marsh? They had to start by reclaiming land from the water. The first Venetians found areas with several pieces of land sticking out of the water in close proximity to one another and drove wooden piles into the clay to mark the land they intended to build on. Then they evacuated the water using buckets. Once everything was dry, they filled in the hole to create a piece of flat, buildable land.
The story of Venice is that of the creation of a city out of nothing. They were building in many places at once, both within the city, where they were working on the canals and marshes, and also outside the urbanized area, because they were gradually taking back more and more land from the water. The city limits were constantly being redefined. It was a very impressive collective project that lasted for centuries. They created the city and the land itself.
This ingenious technique was used to build the entirety of Venice. It's the foundation of the whole city. Today, the amount of land that has been taken back from the lagoon is more than 80%. At first, the Venetians built their houses out of wood, a technique that quickly proved to have its drawbacks, as the city was regularly ravaged by fire. So they decided to build out of stone. Yet this choice of building material came with its own problems.
Building with stone in a place like Venice is really challenging because they are essentially building on mud and water and swampy land. So they have to be quite ingenious about the way that they build, especially once they start using heavier materials like stone.
In order to keep their city above the waterline, the builders were constantly experimenting with new techniques. The muddy terrain where the first houses were built was too soft for stone structures, so they had to reach a layer where the soil would be strong enough to build on. It was then that they discovered Caranto, an ancient layer of clay between 3 and 9 meters below the surface. This layer of subsoil was stable enough for them to construct stone buildings on.
It was a huge discovery for the builders of Venice. When they realized that beneath the mud, there was the famous Caranto, a layer of sturdy clay and hard sand that offered sufficient support for them to start laying the foundations for our houses and palaces.
From that moment on, the medieval engineers started refining different building methods depending on how deep the Caranto was and how heavy the future buildings would be. The first step was to dry out the zone they wanted to build on. The builders started by creating a sort of temporary work basin that was protected from the water by provisional structures known as cofferdams, a cassette in Italian, composed of 2 rows of piles driven into the soil. The space between the piles was filled in with mud to make the temporary construction impermeable. Next, they got to work on the foundations. In most cases, if the Coranto was 3 meters deep or less, the builders would start by placing a few rows of wooden piles, known as pali in Venetian, to support the future walls. For particularly heavy buildings, however, the Venetians placed wooden piles across the whole footprint of the future building, thus creating a solid surface to build upon. The piles were placed very close together in concentric circles, from the exterior to the center of the surface that needed to be consolidated. This latter technique was used to build numerous clock towers, which are very tall and extremely heavy.
Constructing the foundations of Venetian buildings was very hard work. We calculated that they needed 36 piles for a single square meter.
The piles measured 2 to 3 meters high and 20 centimeters across, and were carved into a point at the end to make them easier to drive into the soil. Burying the pali was a very delicate operation because a single wrong move could damage the Coranto. The process required delicacy and patience and was reserved for specialized workers.
It was a very complex operation in which they would hold on to a pole and use a very heavy drop hammer to hit the upper part of the pile with a lot of force until it was driven down to the legendary Coranto.
Then, in both techniques, the piles would be covered with a floor, the zatterone, composed of 2 successive layers of crisscrossed planks. This distributed the load of the future building. Finally, the wooden floorboards were covered with layers of Istrian stone, a compact rock with low porosity, making it perfectly suited to the corrosive, brackish water of the lagoon. So much so that the thickness of these layers was calculated based on the height of the tides. These stone foundations were impermeable, keeping the Venetians dry. The foundation was finally laid. The technique used to lay foundations had an effect on the geography of the city. Once the piles were put in place, they remained there forever, not only because of the high cost of such an operation, but also for another very unique reason.
Even if a building is completely destroyed, the foundations remain because they're protected by the mud around them, meaning they don't deteriorate or lose any of their substance. They don't turn to dust like wood does when it's exposed to the air.
Whenever renovations are necessary, all attempts are made to leave the foundations in place without touching them. If we were to flip the city upside down, we would find an immense forest composed of millions of piles, many of which date back to the 11th century. These techniques, which were revolutionary at the time, have survived through the centuries. Once the foundations were laid, construction could begin on the various buildings and residences. In Venice, building was highly regulated to adapt to the constraints of the environment. In order to relieve the load on the piles, buildings were designed to be as light as possible. Every detail mattered. Instead of using heavy Istrian stone for the walls, the builders chose to use brick, a material that is simultaneously sturdy, lightweight, and resistant to fire, which they then covered with a coating.
Venice is not so much a city of stone as it is a city of bricks. Why? Because bricks cost less and could be produced on site, as well as being lightweight. Given the technical constraints of building in Venice, the weight of the building material was of considerable importance.
In the interest of keeping things lightweight, Venetian houses have never been built very high, rarely surpassing 3 stories. Finally, the palace facades, often decorated with delicate columns, were pierced with large windows. In this unique city, the weight restrictions inspired a unique architectural style, one that's elegant and reminiscent of lace, which came to be known as the typical Venetian style. But all of these techniques weren't enough to overcome yet another challenge. The muddy soil in the lagoon was prone to shifting. How could they ensure the buildings would be able to withstand movement in the terrain without collapsing? The builders of the time came up with yet another brilliant, innovative solution for this non-inconsiderable problem, giving the buildings themselves the ability to shift and move. For example, they used lime rather than cement when laying their brick walls. Lime acts as an effective mortar while remaining flexible. Inside the houses themselves, the dividing walls and floors also had to be able to withstand this movement. The Venetian engineers came up with a fantastic plan: building dividing walls that could adapt to the movement of the terrain.
One of the most important structures, maybe the most famous Venetian invention, is corzoni. They're separating structures, dividing walls made of wooden planks. The planks were placed vertically to hold the floor in place. Then, on either side of the vertical planks, they nailed diagonal planks into place. Then the whole structure was covered in plaster. This structure was found throughout the house, was almost like a trellis.
This technique makes the partition walls flexible and prevents houses from collapsing. The plaster covering the walls merely needs to be redone from time to time. The Venetians were pioneers in this domain. Trellis structures such as these didn't become common until the Industrial Revolution nearly 500 years later. Finally, to prevent the building from tearing apart and to reinforce the structure even more, the floors were attached to load-bearing walls using long metallic rods that can flex and move at will.
The risk for any building is that its weight could pull it off balance, causing a collapse, especially for buildings that have a lot of decoration on their facades, such as statues, for example, which obviously pull the building towards the exterior. Therefore, to minimize that imbalance, they used a series of iron tabs to attach the load-bearing walls to the floors on every story, all the way up to the attic. You can see them from the outside in areas where the plaster has fallen off. You can see blocks of white stone. That's where the iron bars that go all the way through the floor are attached.
Finally, to cover the floors, they needed something that would be able to move with the building. The Venetians perfected a unique material known as terrazzo. a mix of terracotta and lime combined with fragments of mirror, pearl, or glass.
Terrazzo is another typically Venetian invention. It's undoubtedly the most interesting element of any house because it absorbs the movement of the terrain. That movement creates micro fissures, but they remain very discreet.
Flexible, elastic, and adaptable, Venetian buildings are almost alive, changing shape as the soil shifts beneath them. Today, the effects are apparent. Balconies have been deformed, and cracks have appeared on the facades of certain buildings. Yet not a single Venetian palace has ever collapsed. They can still be admired throughout the city today. Despite the consistency in architectural style, the overall effect is far from repetitive. Variations in height, color, and style create many different atmospheres. This can be observed in the facades of the palaces along the Grand Canal, which echo its shape. Once the rules had been set and the building techniques perfected, the city was ready to grow. But there was also another field in which Venice surpassed all other cities, which enabled it to consolidate its power: shipbuilding. Venice had always been home to excellent shipbuilders, a necessity in this city where most people get around by boat. This advantage enabled La Serenissima to set off to conquer the seas with their highly advanced fleet. The city built the arsenal very early on.
The arsenal is a formidable shipyard, as well as a depot where raw materials were stored. It was created early on, just like in Genoa, which was Venice's rival in the late 12th century.
Hidden behind the red brick walls, this nearly 25-hectare complex was the largest factory in the world in the 16th century, employing nearly 16,000 workers.
The Venetian fleet was exceptional. It is really the backbone of Venetian power because this provides the ships that they need, both for commercial shipping and then also for war, and particularly as they expand to become a great empire. They're very innovative in their shipbuilding. They build some of the most technologically speaking advanced ships in the world at the time.
They also innovated when it came to their methods of construction. For the first time in the world, the frames of the ships were moved along a production line in a very precise order, just like in factories today. In the dry dock, the shipwrights would start by building the frame, then applying the wooden planks to the outside. As soon as the hull could float, it was moved from one dock to another. There they would add the cabins, then the masts, then any other equipment, such as ropes, sails, cannons, anchors, and oars.
There was no waiting. It was almost like an assembly line, like the kinds of assembly lines that cars are built on today.
At the peak of the arsenal's production, the workers could build nearly 1 galley per day, which was a remarkable feat at the time. Venice was the proud owner of an extraordinary fleet, making it the first colonial empire and one of the most powerful cities in the medieval world.
The Venetian fleet was invaluable in contributing to the power of the Republic. They had a fleet that was both military and commercial in nature. It's also important to note that the commercial expansion of Venice was supported and accompanied by a very aggressive policy, which is to say that the war fleet also explained and promoted the rise of the Venetian economy.
That's an understatement. In the year 1400, the average income for a resident of Venice was 15 times that of London or Madrid. This wealth was translated into the city itself. One project was particularly important to them, that of building a bridge connecting the two banks of the Grand Canal, which turned out to be much more difficult than they expected. The Grand Canal is as wide as 60 meters in places, a seemingly impossible span. Yet connecting the commercial district of the Rialto to the political and religious district of St. Mark's was becoming increasingly important. Architects had been trying to build a solid bridge for centuries, but they all failed one after another. The first floating wooden bridge wasn't built on the Grand Canal until 1181. We don't know how it was destroyed, but subsequent bridges all met with the same fate. In 1310, the new bridge, which included a section that could be raised to let sailboats pass, was burned down during a protest. It was restored, then collapsed in 1444 and again in 1524 due to excessive traffic.
In the 16th century, once the wooden bridge collapsed yet another time, the Venetians decide that they need to build a stone bridge. The architect who wins the commission is called Antonio da Ponte. Ponte actually means bridge. And his design, which even though it was quite criticised at the time, was the one that was chosen and is actually the one that stood the test of time because the bridge is still standing today, even with the hordes of people that go across it every day.
The structure he had in mind was composed of a single arch of Istrian stone more than 28 meters long, weighing nearly 9,000 tons, almost as much as the Eiffel Tower, which was very heavy for the muddy soil of the lagoon. To counterbalance the lateral force of the arch and prevent it from collapsing, 6,000 wooden piles were put in place on either side at 3 levels. A very original solution.
He designed a foundation with wooden piles on multiple levels. There were 3 steps, one lower down, one in the middle, and one at the highest level. This inclined structure supports the horizontal weight of the bridge. The structure would have collapsed if all the piles had been placed at the same level. But the architect came up with this idea of creating a staircase, which had never been done before.
On top of these foundations, they placed massive blocks of stonework to act as the abutment. The stones were positioned on an incline opposite to that of the arch to counterbalance its force once again, and covered with 2 rows of horizontally placed stones. After 3 years of construction, the bridge was finally inaugurated in 1591, becoming one of the most iconic symbols of Venice. It's a remarkable feat of engineering, given the marshy environment.
The design is a wonder of engineering. It was all about creating a bridge that must remain standing.
The Rialto Bridge was just one of the many constructions undertaken in La Serenissima. From the 13th century on, the Venetians were determined to make their city into the New York of the Middle Ages. To borrow a quote from the famous French architect Le Corbusier, St. Mark's Square became the embodiment of Venice's power.
The political and religious functions of the city of Venice are really concentrated in Piazza San Marco or St. Mark's Square, and this is as far back as the 8th or 9th century when they start building some of the most important political and religious buildings in that square.
The seat of the city's political power was founded in the Doge's palace. It resided primarily with the Doge, the leader of the Republic of Venice. The first iteration of the palace was built in the 9th century, but the building as we know it today, a stunning example of Gothic architecture, is the result of numerous reconstructions and expansions that took place from the 13th century on. The bulk of religious activity took place in the building next door, St. Mark's Basilica.
The Basilica of San Marco was originally the Doge's private chapel, actually, although it grows to be the most important church in Venice. It was constructed originally for around the 9th century after the relics of St. Mark had been stolen by Venetian merchants from Alexandria in Egypt. And it was considered that they needed to build an important church to house these relics because St. Mark was one of the 4 evangelists, and his relics really brought this new, great, important religious power to Venice as well.
As is often the case in Venice, the building we know and admire today has been rebuilt and embellished many times. Unlike the Doge's palace, however, the shape of the church has not changed. It's shaped like a Greek cross, composed of 4 equal arms, each one topped with a cupola, with another dome in the center. It's one of the very few Byzantine churches found in the West. The dimensions of the original building were already very impressive, at 76.5 meters long and 62.6 meters wide, which is huge for Venice. But from the 13th century on, the Doge's palace was constantly being expanded, and it eventually dominated the basilica. So the architects started looking for a way to elevate the domes without adding weight to the building.
They built large wooden roofs that they made considerably higher, making the domes visible once again despite the presence of the new Doge's palace, which had probably started to hide them.
The wooden superstructures were inspired by shipbuilding techniques. They are composed of multiple wooden frames that fit together in a very complex way. The addition of an inner framework reinforced the structures and gave them greater stability once the planking, the pieces of wood traditionally used on the outside of a ship's hull, or in this case the roofs, was nailed onto the rest. Finally, the beams were covered with thin lead plates.
What makes these structures so complex is how intricately the various elements fit together. Even when we compare them to how ships are built, it's hard to say which elements are tension bars, and which are compression bars, because it depends on external criteria. For example, the wind can change the behavior of internal structures by transforming compression bars into tension bars. It's exactly the same for wooden ships. There were no churches or buildings that existed at the time that could have been used as an example. The construction of the 5 domes of St. Mark's Basilica represented a brand new innovation on the part of the carpenters, who, as they obviously had experience in shipbuilding, had the necessary skills to carry out such a project.
Thanks to this feat of engineering, the domes of the basilica can still be seen from afar as you approach St. Mark's Square from the water. Throughout the medieval and Renaissance eras, the center of the city was constantly being transformed, turning it into the architectural masterpiece we admire today. But it was actually the entire city that was being embellished and expanded upon. By the 1500s, Venice had a population of nearly 170,000 people, almost 3 times its population today. It was the most populous city in Europe at the time. The Queen of the Adriatic was at the height of its power. Nevertheless, this population increase made one of Venice's biggest problems even more urgent: maintaining a supply of drinking water in the city. Despite being surrounded by salt water, Venice has always been short on fresh water.
Most cities, regardless of their size, are built in close proximity to a source of drinking water, whether it be a river, lake, or well, where water can be drawn from. Water for drinking, cooking, and building. There was nothing like that in Venice. Obviously, there are rivers feeding into the lagoon, but once they get there, they're contaminated by seawater, making the water unusable. That's why they came up with the extraordinary invention known as the Venetian well. They shouldn't really be called that, because they're not actually wells, technically speaking.
In fact, these so-called wells are actually large underground chambers. They consist of a vast cistern 5 to 12 meters across, coated with several layers of clay to make them impermeable. Inside each tank, the Venetian well diggers spread a layer of pebbles atop which they built a cylindrical conduit made of bricks. Then they filled the tank with a thick layer of fine sand. On the surface, the soil was hollowed out slightly to direct rainwater into stone drains. From there, the water was carried into pipes known as cassoni that released the water into the soil. It would be slowly filtered by the sand before reaching the pebbles and soaking into the brick conduit, in accordance with the principle of communicating vessels. This conduit could then be used like a normal well.
I think what I find most striking about the history of Venice is their ingenuity and their ability to adapt, using limited technical means, to the environment in order to survive. How they got their water is undoubtedly one of the most remarkable examples, because there was no water available, yet they were still able to provide water for a city that had as many as 170,000 people living in it, which is considerable in size.
Nearly 600 of these innovative rainwater cisterns were put in place throughout the city, on public squares, and even in the interior courtyards of some of the richest residences. They were essential to the inhabitants' survival and remained in use until the end of the 19th century. Over the course of its history, the Venetians managed to overcome numerous obstacles related to their environment. But at the end of the Middle Ages, the lagoon was at risk of disappearing. In the 15th century, they started taking drastic measures to save their city.
Venice was particularly fortunate because, after being built and becoming a very important city, it was also governed very well over the centuries. The Venetian government preserved not only the city, but also the lagoon, because it was an important natural resource for Venice. It was used for fishing, farming, sailing, and more.
One issue became especially critical: the potential drying out of the lagoon.
The lagoon originally had a number of rivers flowing into it, most of which flowed down from the Prealps into the basin of the lagoons. All those waterways carried alluvium with them, and the problem with alluvium is that it blocked the lagoon basin by creating deposits of sand, sediment, and more, thus preventing the water from circulating.
For the Venetians, having their feet above water was unimaginable. They realized that to save their lagoon, they would have to undertake some very ambitious constructions.
From the 16th century until the end of the 17th century, they worked very hard to change the course of nearby waterways. These were massive jobs in terms of the methods, technology, and labor force that were required. Nearly all of the waterways leading to the lagoon were rerouted to the sea to prevent the lagoon from being turned into a marsh.
It was a gigantic project. In the long term, they really did a massive amount of work on the coastline and the course of the river network.
Venice's fate is still inextricably linked with its environment today. But now it's facing a different threat: rising water levels. Over the last few decades, the problem has accelerated, all while the city continues to sink. According to a report published by the Intergovernmental Panel on Climate Change in 2019, the 1,000-year-old city could disappear by the end of the century. It's a veritable race against the clock. Inside the city, the issue is apparent. Take the Basilica della Salute, for example. It was only built in the 17th century, yet just 400 years after its construction, it already finds itself at the water's edge. At least 5 steps that were originally above water level are now constantly submerged. The bell tower on the Campo Sant'Angelo is leaning dangerously due to the subsiding soil beneath it. Venice is undeniably sinking. But why? Partly due to work that was done less than a century ago. In the early 20th century, in order to compete with the other Mediterranean powers, the city built a large commercial and industrial port, the Port of Marghera.
The construction of the industrial zone not only created pollution, which means we now have to do costly decontamination works throughout the zone. Another consequence, however, was that part of the lagoon was filled in, whereas the early Venetian architects had always rerouted waterways just to avoid such a thing.
And even worse, when the industrial manufacturers needed a source of fresh water, they decided to pump it out of the water table beneath the city. In the 1950s, nearly 40,000 cubic meters of water, the equivalent of 16 Olympic-sized pools, were being removed each day. Naturally, little by little, the reservoir was emptied out. The water table collapsed on itself, and Venice dropped 9 centimeters. Less spectacular, but perhaps even more destructive, is the daily passing of motorboats which damage the lagoon. Fortunately, since August 1st, 2021, under pressure from UNESCO, the city of Venice has banned access to the island of Rialto to cruise ships weighing more than 25,000 tons. This is a step in the right direction, but is far from solving all the problems.
It's important to point out that the taxis and other motorboats that circulate on the lagoon also endanger the banks and the foundations. And because of that, they're being eroded more and more every day.
But Venice's worst enemy, perhaps the most dangerous of all, is global warming.
Venice is very sensitive to climate change, perhaps more so than any other city in the world. Because even when the average sea level rises by just a few centimeters, it already has a significant impact on life in the city.
Climate change has caused water levels to rise by 23 centimeters in Venice in just over 100 years. According to our calculations, a subsidence of 9 centimeters plus a rise in water levels of 23 centimeters means water levels have risen by 32 centimeters in Venice in just a century. The city is paying the price. St. Mark's Square is located at the lowest point in the city, just 73 centimeters above sea level. 115 times per year, the water rises by 90 centimeters, flooding the square. 60 times per year, water levels reach 110 centimeters. This is caused by what Venetians call acqua alta, a tidal phenomenon that partially floods the city.
The way the tides affect Venice is explained by the combination of three natural principles. The first is the astronomic tide, or the gravitational force exerted by the sun and the moon on the surface of the sea. The second is meteorological in nature and is related to the evolution of atmospheric pressure and wind speeds, most importantly the Sirocco and the Bora. And the third is the geometry and morphology of the Adriatic basin, where standing waves form and accumulate.
These exceptional tides have always existed in Venice, but scientists agree that the phenomenon is increasingly a cause for concern.
If we look at the evolution of sea levels compared to the number of episodes of acqua alta in Venice, we find that while average sea levels are increasing according to a linear curve, the frequency of episodes of acqua alta is increasing exponentially.
When an episode of acqua alta exceeds 1.1 meters in height, it causes substantial damage to the city. In 2019, the water levels rose to 1.87 meters, causing 870 million euros worth of damage. This bodes ill for the city, especially because salt water is damaging the buildings more and more. Fortunately, scientists have swung into action. They're constantly looking for new ways to hold off the water's advances. They came up with a large-scale project to protect Venice at the entrance to the lagoon itself. It's such an ambitious project that it took nearly 20 years to complete. The MOSE, a humongous project named after Moses, is designed as a rampart to defend the city from exceptionally high tides.
The idea is very simple in theory, but very complex to put into action. It's still very experimental today.
While the concept may be a simple one, implementing it on such a massive scale is not without challenges. In the 3 mouths to the lagoon, no fewer than 78 mobile flood barriers, controlled from a small artificial island, were installed underwater, each one contained inside a concrete box weighing 25,000 tons. Each flood barrier measures 20 to 30 meters long, 20 meters wide, and 5 meters thick for a weight of 170 to 330 tons. The variation is due to the fact that the barriers must be adapted to the varying depth of the Venetian soil. When the alert level of 1.1 meters is reached, these underwater barriers attached to powerful hinges can be raised in just 30 minutes and withstand tides reaching up to 3 meters in height. Together, they act as a gigantic dam. In 2020, after more than a 10-year delay, the MOSE was used for the first time in a real situation. To everyone's relief, the test was a success. The MOSE has been successfully activated some 50 times since. Yet, despite its efficacy, the MOSE does not have universal support.
There are other issues to consider, such as the long-term effects of the MOSE on the ecosystem. The most distressing question is whether the MOSE will continue to function if water levels keep rising.
According to experts' predictions, the MOSE could remain effective until the end of the century. But there's the rub, because as global warming and the resulting rises in sea levels are picking up speed, the MOSE may reach the limits of its efficacy much earlier than expected.
Maybe measures will be taken on a planetary scale to attempt to slow the rising water levels. This is more than just a Venetian problem or an Italian problem. It's a worldwide issue, and we're linked to the fate of the planet.
Venice seems to be safe for now, but for how long? Over the centuries, Venice has grown in size and wealth, becoming one of the most beautiful cities in the world. Every year, millions of tourists flock to it to admire the stunning churches, palaces, houses, and canals.
The city is truly unique. Just look at how it was constructed, how it was preserved, and how its structures have been embellished, becoming veritable works of art.
Venice was built on the water, and today that same water may be its downfall. But the people of Venice are far from giving up. With ingenuity and determination, they're striving today, as they always have, to preserve La Serenissima for centuries to come.
Venice inspires me and gives me hope because it's a city that has always been able to adapt and overcome all throughout its history.
It's absolutely essential that we preserve Venice because it is really an archive of so many different and important histories, as well as just being a beautiful place to visit. But we need to find ways to preserve it into the future because it is facing such terrible challenges.